All right, what's up? Today we're going to look at solving some trig equations. Now, I don't know if you've watched my other videos, but there's a video right before this one where we start solving trig equations. All right, and in the trig books, there's usually about 3 sections on solving trig equations. The first section is the easier ones, and then the next one's a little bit more difficult, as you can see in the first problem. And then the last one is, a lot of times it's like quadratic equations, like sine squared, where you got to factor it and all that good stuff. So my advice is to watch all 3 videos, because that's going to cover everything. All right. So let's go ahead and get started. And let me say this, to access all the videos, you can just go to my channel and go to Trigonometry lecture playlist, and all the videos are in there. You'll see all 3 of the solving equations. All right, so if you watched the first video, well, let me say this. If you haven't watched the first video, I would go back and watch that, because that sets the foundation for everything. That's going to make this video so much easier. All right, so remember, when we're solving, we need to determine which quadrant our solution's in. Then we need to find our reference angle, and then find all the solutions. All right. So looking at this problem, we've got sine 2 alpha equals square root of 2 over 2. And we want to find all the values between 0 and 360 degrees. I'm going to start off using degrees, and then we'll switch the angle measure to radians. I think it's easier for you to learn it and see what's really going on when we're in degrees first. All right, so cosine 2 alpha equals square root of 2 over 2. But what's important here is cosine 2 alpha equals positive square root of 2 over 2. All right, so cosine is equal to a positive. So where is cosine positive? Cosine's positive in the first and fourth quadrant, right? That's where it's positive. So my solutions are in the first and the fourth quadrant. Now, the thing that you've got to keep in mind, this interval here, this 0 to 360, what that means is we're finding all the solutions where alpha is between 0 and 360 degrees. That's what we're looking for. Okay? Now, important here, alpha. And what is our angle? 2 alpha. So I've got to figure out my interval. Well, they give me what alpha's between, but I need to know what 2 alpha is in between. So if I take this and I multiply it by 2, that'll give me 2 alpha here in the middle. So that's going to give me 0 less than or equal to 2 alpha less than 720 degrees. So I'm finding all the solutions between 0 and 720. All right, because I've got 2 alpha, not alpha. All right, so my solution is in the first and fourth quadrant. Now remember what I said, find your reference angle first. And like I said, if you've watched the first video, all of this is going to make sense right now. Okay? And I'm telling you, go watch the first video if you haven't watched it. All right? Now, I've got to find my reference angle. And remember, your reference angle is an angle measure between 0 and 90 degrees. It's in the first quadrant. Well, you can see one of our solutions is in the first quadrant. So that means the reference angle is one of my solutions. You see that? So the cosine of what is 45 degrees? I'm sorry, the cosine of what is square root of 2 over 2? I was thinking of the answer in my head. Well, that's what? 45 degrees, right? That's one of my solutions. That's my solution in the first quadrant, but it's also a reference angle. It's also my reference angle. So now I need to use my reference angle to get my solution in the fourth quadrant. So let me just draw this first. So there's my first quadrant angle, 45 degrees. That's my solution for the first quadrant, and it's my reference angle, the 45 degrees. Now, let's look at our fourth quadrant angle. So I need this, and remember this is 2 alpha. There's my reference angle, 45 degrees. And so I get 2 alpha is equal to 360 minus 45, which that is 315 degrees. So I've got 315 degrees. That's my solution in the first and fourth quadrant. Now I'm going to erase this because I need some room here. But what we had was, that's what we had right after we multiplied through by 2. All right, so remember this is 0 degrees, 90 degrees, 180, 270, and then back to 360. All right, so what I've done is I've gone around one time and found all the solutions from 0 to 360. That's where the 45 and the 315 come in. Okay, but I've got to find all the angles between 0 and 720. So I went around one time, 360, but now I got to go around again because remember, 360 plus 360, that's 720. So I'm going around 3 times. All right. Now, this is where you've got to dig all that information out of your brain, okay? Do you remember coterminal angles? Okay, so look at this. This is what? 45, right? I go 45, and then if I add 360 to that, that gets me right back there in the first quadrant, right? So another solution would be 45 plus 360. All right, so 45 plus 360, that's going to give me 405. And so 405 would be a solution. All right, so I'm on my way around twice. Okay, now let's take a look at this one. This angle here, right? This angle right here, that is what? That's 315 degrees. But if I add 360 to this, look at this. I'm right back there. I've gone around again. You see that? So I have 315 plus 360. So 315 plus 360. That gives me 675. So 675 degrees. That's my other solution in the fourth quadrant. Now, look at this. Now you might be wondering, well, do you stop right there? Do you only go around twice, or do I need to go around again? Well, let's look at it. Right here, I went around twice, right? I went here and then back to the 45. And that gave me an angle measure of 405. Well, what would happen if I do 405 plus 360? What does that give me? Well, 405 plus 360 is 765. And I got to stop at 720, so I can't go around again. Okay? All right. So I've got 4 solutions here, but notice what this says. This is 2 alpha equals this. I need to know what alpha is. So I need to come and divide everything by 2 to get alpha. So that's going to give me alpha is 22.5 degrees. And then I've got 315 divided by 2. That is 157.5. And then I got 405 divided by 2. That is 202.5. And then I got 675 divided by 2. That is 337.5 degrees. And this is my answer. All right, so I hope that problem made sense. If not, okay, if you're still a little fuzzy on it, hang with me in the video, okay? Because I think after we get finished with all the examples, it'll all clear up, all right? So looking at this next problem, I think this is really going to help because it's you can see it's changing from 2 times the angle to 3 times the angle. So let's go through this problem before you make a decision on if you understand it or not. And this problem here is actually I've got it in radians, but let me do this. Let's go ahead and do this problem in degrees. We'll do one more problem in degrees, and then we'll switch to radians, okay? All right, so I want to find all the solutions between 0 and 360, okay, for x, okay? See, our angle's x now instead of alpha. I'm going to do it for x. But what do I have? I've got 3x, and this is for x. So what do I have to do? I have to multiply this by 3. So that's going to be what? Between 0 and then 360 times 3, that is 1080 degrees. Okay? All right, so I've got to find the solutions. Now, can you guess what we're going to do? Look, up here when it was 2 alpha, what did we do? We went around twice on each of the first quadrant angle and the fourth quadrant angle. We went around twice. What do you think we're going to do here? If you guessed we're going to go around 3 times, you would have guessed right. Okay? All right. So, the thing I'm getting at is I kept saying at the first of the video to go back and watch that first video. Okay? Because the only thing that is different in this one is when we added the 360 to go around the second time. That's the only thing that's different. Everything else is the same. Okay? That's why it's so important to understand that first video and then come into this one. Because if you understand the first video, all this stuff is easy because, I mean, that's the whole key to it. Pretty much. Okay? All right. So let's look at this. All right. So we've got tangent. So tangent is equal to what? Negative. Okay? I don't even care about the square root of 3 over 3 right now. All I'm saying is tangent is equal to a negative. So where's tangent negative? Tangent is negative in the second and fourth quadrant. You see that? So remember what I told you at the beginning of the video, and if you watched the first video, what did I say? You determine what quadrants your solutions are in. All right? Determine what quadrants your solutions are in. And then, what do? Find your reference angle. Find your reference angle. Remember, your reference angle is the angle in the first quadrant. Okay? And remember this, the sine, cosine, or tangent, the sine, cosine, or tangent of a reference angle, whenever you take the sine, cosine, and tangent of a reference angle, you get a positive number, right? You get a positive number. Well, let me ask you this. In this first problem, notice the reference angle was one of the solutions. That's because one of my solutions was in the first quadrant. It was in the first and fourth quadrant because this is positive. But if you look down here, this equals a negative. Reference angle isn't a solution, is it? Because one of my solutions are not in the first quadrant. They're in the second and fourth. So I need to find my reference angle first. Yes, I know everything about that unit circle. And I know a lot of you, your teacher taught you that unit circle and told you to memorize that unit circle, and that works fine and everything, but it don't work all the time. Does it work in this situation? Yeah. But it's not going to work on some of these that we do. At least I don't think. I don't know. I can't remember if I have maybe it will on all of these. But in that first video, you'll see where the reference angle doesn't work. Okay, so watch the first video. All right, so let's find the reference angle. So this is going to be tangent of 3x, and I'm going to use this prime here, okay, this little mark here. That just means that's the reference angle. If you notice in some books, when they talk about reference angles, they'll label the reference angle like theta prime or theta with a bar over it or theta hat, something like that. Different books will represent the reference angle with different notation. Okay, the book I'm using uses this, so that's what I'm going to do. So this just means reference angle, because remember, I've got to find the reference angle first. All right, so that is equal to what? Square root of 3 over 3. You see that? That's equal to square root of 3 over 3. Positive square root of 3 over 3. Well, why did you change it to positive? That might be a question you're asking. Why did you change it to positive? Because I'm looking for the reference angle. Okay? The tangent of the reference angle is positive, which is in the first quadrant. I'm looking for this first quadrant angle right here. That's my reference angle. It just so happens in this problem, it's not one of my solutions like it was in the first problem. Okay? So I get my reference angle. Well, the tangent of what is square root of 3 over 3? Well, that's what, 60 degrees? All right. So there's my reference angle. So now I have to use my reference angle to find my solutions in the second and fourth quadrant. So I'm going to get 3x is equal to, now I'm going to start listing my solutions. Okay. So let's look at this. So my second quadrant angle, there's 3x. Here's my reference angle, 60 degrees. So I get 3x is what? 180 minus 60, which is 120. So 120 is one of my solutions. All right. So what am I doing right now? I'm going around the first time. So now let's find our solution in the fourth quadrant. So my solution in the fourth quadrant, I need 3x. Here's my reference angle, 60 degrees. So I get 3x is 360 minus 60, which is 300 degrees. Okay. So I went around once. Now I've got to do what? I've got to go around again. In fact, I've got to go around how many times? 3. See? 3 times I've got to go around. So let's look at this. So let's just start with the first quadrant. Let's go around one more time. Okay, we went around once to the 120. Now let's add 360 to go around again. So that's 120 plus 360, and that is going to be 480. So there's 480. Now let's go around here. So from here to here, that's what, 300? That's going around one time. So let's go around again. So I'm going to add 360. So that's going to be 660. All right. So that I've gone around twice, haven't I? So now I got to go around one more time, don't I? Got to go around one more time. What do you think I'm going to do? I'm going to add 360 again. Coterminal angles. That's what we're doing. All right, so that's going to be 480 plus 360. Yes, I could add 720 to the 120 if I wanted to, but I'm just going to add 360 to the 480. So that's going to give me 840. So 840. Now, for my fourth quadrant angle, I've gone around twice. Now I got to go around one more time. So that's going to be 660 plus 360. So 660 plus 360, that is 1020. And so 1020. All right. So that's what 3x equals. Okay. And you can see, you know, you don't need to add 360 again, because if you do 840 plus 360, that gives you 1200, which is larger than the 1080. Okay. All right. So what do I do now? Well, I got to figure out what x is, don't I? X is what? I'm going to divide everything by what? 3. And so that's going to be what? 40, 100, what is that? 160. I'm going to double check myself on all the, well, not all of them, but some of them. That's what? 220. And then 840 divided by 3, that's 280. And then 1020 divided by 3, that is 340. Okay. So double check myself, because if I divide or multiply something wrong, man, do I hear it in the comments. I don't know what I'm doing when I do that. All right. All right, so there's your answer. That's it. Okay. That's all you're doing. Okay. I'm telling you, and I know I've said it again, and you're probably laughing at me right now. Watch the first video. If you get it, this is easy. The only thing we're adding, it's like we're adding to that first video by going around twice or 3 times or whatever. Well, what if this was 4x? What do you think would happen? Well, we'd go around one more time, wouldn't we? We would add 360 to the 840 and 360 to the 1020. Okay? Don't make this more complicated than what it is. Okay? All right. All right, so let's look at this one. Now, let's switch to radians now. We've gone through all the stuff in degrees. You should get this by now. All right. All right, so let's see what we have here. We got cosine alpha over 2 equals 1/2. And I'm finding the solutions between 0 and 2 pi. All right, so my solutions are in the what? First and fourth quadrant, right? First and fourth quadrant. That's where cosine is positive. Let me ask you this. Is my reference angle a solution? Absolutely. See, one of my solutions is in the first quadrant, so my reference angle is in the first quadrant. So I don't need this extra step here. These extra steps here are finding the reference angle, because the reference angle is one of my solutions. All right. Now, remember this between 0 and 2 pi, that's for alpha. But what do I have? I have alpha over 2, don't I? I have alpha over 2. So let me just write this out, what this is actually saying. That's what it's saying. So I need alpha over 2, so I'm going to divide everything by 2. So 0 less than or equal to alpha less than pi. All right. So that's what I'm looking for alpha. All right. So we get what? Alpha over 2 is equal to what? Cosine of what is 1/2? 60 degrees, or what? Pi over 3. That's my first quadrant angle, right? That's my first quadrant angle. All right. But then, what do we have? Oh, I'm sorry, this should be alpha over 2. I forgot the 2. All right, so now what do we have? We've got an angle in the fourth quadrant, right? But I'm done. I'm done. So now I need to multiply everything by 2. And so I get alpha is 2 pi over 3. And there's my answer. Now, you're sitting there thinking about, well, why? How come I didn't find the fourth quadrant angle? Because alpha over 2 is between 0 and pi. There's 0, pi over 2, pi, 3 pi over 2, and then back to 2 pi. See, alpha over 2 is just in the first two quadrants. And the only place where cosine is positive 1/2 is in the first and fourth quadrant, but I can only look at the first and fourth quadrant because of this. So I don't even need to check that. You see that? I don't even need to check it. All right. So I hope that made sense. Okay, it's important that you do this to see what interval you're looking at. All right. All right, so let's take a look at the next problem. All right, so we've got cosecant alpha over 3 equals 2. All right, so let's see what we've got here. So first we can determine our solution is in the first and second quadrant, because that's where cosecant is positive. Remember, cosecant and sine are positive in the same quadrants, first and second. Now, once again, this is what? 0 less than or equal to alpha less than 360. But I've got to divide by what? 3, right? Because I've got alpha over 3. So that's going to be 0 less than or equal to alpha over 3 less than 120. Okay? All right, so let's find our reference angle. Is our reference angle going to be a solution? Yes, our reference angle will be a solution. It's in the first quadrant. You see that? One of our solutions is in the first quadrant. So I get alpha over 2 is equal to, I'm sorry, I'm jumping ahead of myself, aren't I? Cosecant. Cosecant of what is 2? Well, that's something we may not quite remember. Okay, we probably don't remember that one. But we know we can write this as the sine of alpha over 2 is 1/2, right? Because cosecant and sine are reciprocals. And it's not alpha over 2, it is alpha over 3. Man, I'm having a time with this problem, aren't I? Writing down all kinds of stupid stuff. All right, so I've got alpha over 3 is equal to, well, the sine of what is 1/2? The sine of 30 degrees, right? The sine of 30. That's my first quadrant angle. Well, now I need my angle in the second quadrant. So there's alpha over 3. There's my reference angle, 30. And so I get alpha over 3 is what? 180 minus 30, which equals 150. And what can I do with that? I can put a big old X through that, can I? There's my only solution, 30 degrees. Why is that? 150 does not fall within that interval, does it? You see that? Doesn't fall within that interval. So can't use it. Okay? So that's my only solution. I need to multiply everything by 3. So I get alpha is 90 degrees. And there's my answer. All right. Hopefully you're getting this and it's starting to make sense. All right. All right, so how about this one? Wow. This one doesn't look very fun at all, does it? See that? That doesn't look fun. Well, let's see what we've got. So we've got this equation here. Man, that's got squareds in it. Look, these angles are different. That's 2x and this is x. Man, what in the world do we do on that? Well, let's see. You're going to have to use your trig identities, okay? You're going to have to use your trig identities. So let's look at this. Isn't this sine 2x plus 1 equals 0? Can we do that? Because don't we have sine squared plus cosine squared is 1, right? See that? Sine squared plus cosine squared is 1. So that helps a lot, doesn't it? That makes it easier. So now we just got what? We've got sine 2x equals -1. So there we go. That's what we're looking for. That's what we need to solve for. Now, that sign is negative, but it's -1. And if you watch the first video, remember what I told you. Whenever you get sine or cosine equals a 0, a 1, or a -1, that's one of those quadrantal angles. That's like either 0, 90, 180, 270, or 360. Okay? So, and also in that first video, we went over how to look at that. There's the graph of sine. There's pi. There's pi over 2. There's 3 pi over 2. And there's 2 pi. And what do I need? I need where it's -1. Where's sine -1? At 3 pi over 2. See? It's at -1. But before I keep working this, you see the 2x here? That's my angle. So what do I have to do here? This is 0 less than or equal to x less than 2 pi. If I multiply everything by 2, that's 0 less than or equal to 2x less than 4 pi. I'm going around twice, right? So I get 2x is equal to what? 3 pi over 2. See that? That's going around one time. So I got to go around again. So what am I going to do? I'm going to do 3 pi over 2 plus 360, or plus what? Since I'm in radians, plus 2 pi. And that's going to be what? 7 pi over 2? Yep. 7 pi over 2. But that gives me 2x. And what do I need? I need to know what x is. So I need to come up here and multiply all this by 1/2 to get rid of this 2 right here. So that's going to give me x is what? 3 pi over 4. And this is 7 pi over 4. And there's my answer. All right. All right, so let's take a look at another one. Okay, so how about this one? Well, it's kind of like the first one, but a little bit different, right? It's a little bit different. I've got sine 2x minus sine x equals 0. Well, the problem I have here is the angles are different. One's 2x and one's x. So I need to see if I can get them all the same, the same angle. So couldn't I do this? Right? How did I get that? Well, that section, if you're taking trig, that section wasn't too long ago. Double angle identity. Remember? Double angle identity for sine. Look it up. All right, so the main thing here, we got our angles the same. So we need to solve this. Well, how do we solve it? Well, if you notice, I've got a common factor of sine. So I can factor that out. So that's sine x times 2 cosine x minus 1 equals 0. All I did is I factored a sine out. That's all. All right. So how in the world do we solve this? Well, it's kind of like back when you were in algebra solving those quadratic equations. You had the two factors here. So you just set each one of them. You set each one of them equal to 0. So sine x equals 0, or 2 cosine x minus 1 equals 0. So this one I would get what? Cosine x equals 1/2, right? All right, so there we go. So now, guess what? All it is, it's like now you're solving two problems side by side. You just work on this one and then work on this one. So let's do the sine x equals 0. When do we get there? Remember what I told you, sine or cosine equals 0, 1, or negative 1. It's going to be one of those solutions like this right here. Okay? All right, so just real quick, let's just draw sine. So that's 0 pi over 2, that's pi, that's 3 pi over 2, and this is 2 pi. So where is sine 0? Well, that's when x is 0, see right there. And when x is pi, see sine is 0 there at pi. And then it's also 0 at 2 pi. But we don't do anything with that. That's our answer. So why do we not include the 2 pi? Because there's a parenthesis on it. The 2 pi is not included in the solution. Now, if they gave you this in the problem, then you would include the 2 pi. Okay, but that's not what they gave us. They gave us we have a parenthesis right here, so that means the 2 pi is not included. All right. Now, so we took care of the first one. Now let's look at the cosine x equal 1/2. Now we just go back and we work it like we did earlier. This is a problem I think we worked this probably the same exact problem in the first video. So now I'm working on cosine x equal 1/2. Well, my solution's in the first and fourth quadrant because I got cosine equals a positive number. All right, so I need my reference angle. Is my reference angle one of my solutions? Yeah, I'm in the first quadrant. One of my solutions is in the first quadrant, so the reference angle is a solution. So that's x equal, well, the cosine of what is 1/2? 60 degrees, but we're in radians, so that's pi over 3. All right, now I need my fourth quadrant solution. See, that's why I'm finding my reference angles, so I can find all of my solutions. There's x, there's pi over 3, and so x is what, 2 pi minus pi over 3? That is what, 5 pi over 3. So this is 5 pi over 3. And so there's all four solutions. All right, let's look at this one. All right, so here's our last problem. So this doesn't look too fun, does it? So let's see what we've got here. So I've got 2 sine plus 1 equals 0. So probably what I need to do here is what? Solve for sine, right? So let's do that. So I'm going to get sine of x plus pi over 6 equals negative 1/2. All right, so I've got sine equals a negative number. Sine equals a negative number. So that tells me that my solution is in the third and the fourth quadrant because that's where sine's negative. So let me ask you this. Is our reference angle one of our solutions? No, because one of our solutions is not in the first quadrant, so the reference angle is not a solution. Well, we need to find the reference angle, don't we? So just like we did before, let's just put the prime right there to represent our reference angle. So remember, the sign of a reference angle is a positive number. And so I get x plus pi over 6 is equal to what? Well, the sine of what is 1/2? The sine of 30 degrees, right? So 30 degrees, that is pi over 6. And remember, that's our reference angle. That's our reference angle. So we've got to use our reference angle to find our third and fourth quadrant solutions. So let's do that. So let's get the third quadrant. So there's my angle. There's my reference angle. And so I get what? Pi plus pi over 6. That's going to be what? 7 pi over 6. How about that? That's going to be 7 pi over 6. So now let's find our fourth quadrant angle. There's our angle. There's pi over 6. And so this is going to be what? 2 pi minus pi over 6, which that's what? 11 pi over 6. All right, so I get x plus pi over 6 is equal to 7 pi over 6 and 11 pi over 6. All right, so is that my answer? No, that's not what x equals, is it? That's not x. That's x plus pi over 6. So what's x? Well, I need to subtract pi over 6 to everything, don't I? So that's going to be x is equal to, well, 7 pi over 6 minus pi over 6 is 6 pi over 6, which that's pi. And then 11 pi over 6 minus pi over 6 is 10 pi over 6, which that's going to be 5 pi, is that 5 pi over 3, I believe. Yeah, 5 pi over 3. And so that's my answer. So look, I took the x plus pi over 6 equal to 7 pi over 6, and then the x plus pi over 6 equals 11 pi over 6, and I just subtracted pi over 6 to each side, and got, for here I got pi, here I got 5 pi over 3. That's it. And that's your answer. All right? So I hope all this made sense to you. I hope you feel smarter now, and I hope, and like I said, I hope you watched the first video, and there's a third video. Watch it. It's going to deal more with like quadratics and stuff like that. You may have to use a quadratic formula or complete the square or something like that to solve these things. It's going to be a little more involved. But hopefully you noticed that when we went to find the angle measures, we did it just like the first video. The only difference is we had to do some stuff before we worked the problem, or we had to go around more than once. But it all comes from that first video, solving those basic equations. Okay? So I hope this helped. Check out my other video. Give me a like, share, and subscribe. Thanks for watching, and I will see you later.